Did you know that over 40% of the Earth's surface is devoted to agriculture, carrying out a monumental mission, feeding more than 8 billion lives? Every single day, millions of tons of crops are planted, harvested, and transported, a testament to the immense scale of the most essential industry on the planet. To meet that enormous demand, a new era has emerged, one where colossal machines, autonomous robots, and artificial intelligence are elevating agriculture to new heights with record-breaking efficiency. Today's video will show you how humanity harnesses steel and intelligence to transform every inch of land into treasure, sustaining the present and shaping the future of our planet. In November, the peat fields of Wisconsin and Massachusetts burst into a fiery red, signaling the start of Cranberry Harvest season. Everything begins with what seems like a simple yet crucial ritual: flooding the bogs. As the water level rises to about 20 centimeters, a fleet of egg beater machines rolls in. Their 2-meter-long steel paddles churn the water into powerful whirlpools, dislodging millions of ripe berries from their vines without damaging the plants. Each cranberry contains 4 tiny air chambers, the secret that allows them to float like little red gems. Within just a few hours, the entire bog transforms into a dazzling crimson sea. Specialized tractors then deploy floating booms to corral the massive cluster of berries into one corner of the pond, a key step that not only speeds up collection, but also minimizes fruit loss, ensuring every cranberry is recovered. Once the floating mass is gathered, powerful vacuum pumps come alive. Giant suction hoses swallow waves of gleaming red cranberries, lifting them onto stainless steel conveyors for washing, draining, and sorting before they flow directly into refrigerated trucks waiting at the edge of the bog. Each harvest season, a single farm can collect over 200 tons of cranberries in just a few days. With the help of mechanical marvels that turn tranquil wetlands into a spectacular crimson wonder of North American agriculture. These Pleger pea viners are the true giants, the ultimate masters of the industrial green pea world. Standing over 4 meters tall and stretching nearly 12 meters long, they operate like advanced mobile factories across the fields. In just 1 hour, a single giant can sweep through nearly 10 hectares, harvesting tens of tons of fresh peas, an efficiency that hundreds of manual laborers could hardly match. Yet, sheer power alone doesn't define the Pleger's true class. What sets it apart is its near-perfect mechanical sophistication. At the front, the low-cutting header gently taps the pea plants, lifting each cluster without bruising the pods. Immediately afterward, a spiral conveyor draws the entire plant into the vining drum, where rotating cylinders and vibrating sieves work in harmony, strong enough to separate the peas, yet delicate enough to keep each tender green pearl intact and glossy. Inside the machine's body, streams of compressed air and circulating wind remove leaves, stems, and husks, leaving behind only the plump, vibrant peas that tumble into a massive rear hopper. Once full, a hydraulic arm swings out to unload the peas directly into an accompanying truck, allowing the entire operation to run continuously without a single pause. Thanks to these colossal harvesters, the Netherlands leads Europe in industrial pea production, accounting for over 30% of the region's total, reaffirming its status as one of the world's most advanced agricultural powerhouses. On traditional strawberry farms, the rhythm of harvest unfolds slowly yet precisely, guided by the skilled hands of experienced pickers. Hand-picking ensures that each berry is harvested at its perfect ripeness, with its green stem intact, skin glossy, and natural fragrance preserved. Among rows of lush green leaves, farmers gently lift each strawberry, give it a slight twist, and pluck it from the stem. a motion that seems simple but demands absolute finesse. Once a basket is full, the fruit is immediately taken to a cooling station, racing against time to lock in its freshness and sweetness. But inside high-tech greenhouses, autonomous robotic arms are gradually replacing human hands, marking the pinnacle of modern agriculture. Equipped with multispectral AI cameras and 3D sensors, these robots can detect ripeness by analyzing the hue of red and surface gloss, then command soft grippers to gently pick each berry and place it carefully into collection trays. Despite the steep investment, over $300,000 for a complete robotic system, these machines represent a bold leap forward, bringing agriculture ever closer to an era of intelligent and fully automated farming. This John Deere tractor is carving perfect furrows into the arid soils of Arizona with a massive 16-meter-wide industrial bed, equipped with GPS guidance and auto-track automation, accurate to within just 2 centimeters. With each pass, more than 30 steel plow blades drop simultaneously, tilling, turning, and shaping the soil into perfectly even raised beds, an ideal foundation for crops like potatoes, onions, carrots, melons, and peanuts. In just 1 hour, this powerhouse can form over 15,000 furrows across more than 20 hectares, saving over 80% of the time and fuel compared to traditional methods, a clear testament to the power of mechanization in modern desert agriculture. The rocky, uneven lands that once took farmers weeks to clear by hand have now been completely conquered by the power of industrial rock pickers. With their dual helix tines and hydraulic collection conveyors, these machines act like massive mobile filters moving across the fields. As they advance, dozens of rotating tines dig deep into the soil, digging, rolling, and sifting each layer to separate rocks from earth in a single pass. Stones ranging from 5 to 60 centimeters are gathered by the spiral scoop, then gently carried up a hydraulic conveyor into the rear hopper, where they are compacted and dumped into trucks within seconds. Widely used in Canada, the US, and several European countries, these machines represent the quiet yet crucial first step of every growing season, laying the perfect foundation for the first green shoots to rise from soil that's clean, level, and flawless down to the last centimeter. Not as massive as potato planters or grain harvesters, rice transplanters are compact machines built for precision. Equipped with floating crawler tracks and specialized anti-sinking systems, they're perfectly adapted to the muddy, waterlogged terrain of paddy fields. As the machine moves forward, its synchronized mechanical arms work in perfect rhythm, each motion separating a small cluster of seedlings and planting it into the soil at 30-centimeter intervals, creating perfectly aligned rows of rice. Each transplanter can replace over 30 manual laborers, covering 1 hectare of field in under an hour, 10 times faster than hand transplanting, while boosting yields by 20 to 30% thanks to uniform spacing and precise planting depth. And when harvest season arrives, that mechanical rhythm continues, now stronger and more decisive, with the arrival of the mighty combine harvesters. Across Japan's rice fields, compact Kubota combine harvesters weave through narrow paddies, their floating tracks gliding over the mud without leaving deep marks. At the front, high-speed cutting blades shear the rice stalks close to the ground, feeding them into the rotating threshing chamber, where fans and vibrating sieves separate the grains from the straw. The chopped straw is then evenly spread back over the field, serving as both mulch to retain moisture and natural fertilizer for the next crop. Operating on the same principle but with far greater capacity, machines like the John Deere S-Series, Class Lexion, and New Holland CR Revelation stand as symbols of agricultural power in the US, Europe, and Australia. Each of these giants, over 4 meters tall and nearly 12 meters long, can process up to 50 tons of rice per hour, working tirelessly day and night with near-perfect precision. Thanks to these mechanical marvels, the global rice industry now produces over 750 million tons each year, feeding more than half of the world's population. In California's garlic fields this October, the air buzzes with the roar of colossal self-propelled harvesters, tirelessly turning over the sun-baked soil. At the front, a V-shaped digger blade cuts deep into the earth, lifting each bulb to the surface, while vibrating conveyors and centrifugal fans work in harmony to remove soil, roots, and dried leaves. With every pass, tons of garlic are gathered and poured directly into waiting trucks, turning the harvest into a symphony of steel. Powerful, precise, and commanding. Yet amid this mechanical rhythm, small organic farms still quietly endure in the valleys of Gilroy. There, each clove of garlic is still hand-pulled, gently brushed clean, and neatly laid out to dry under the sun, not only to preserve its natural flavor, but also as a humble tribute to the land that has nourished generations of farmers. Gliding across fields blanketed in delicate white chamomile blooms is a specialized harvesting machine, the Chamomile Harvester, designed specifically for this fragile yet precious plant. Unlike most herbs, chamomile cannot be harvested with rough cutting blades, as even slight pressure can bruise the flowers and cause essential oil loss. Instead, the machine is equipped with a low-speed rotating drum lined with hundreds of soft rubber fingers that gently comb and separate the blossoms from their stems without damaging the petals. At the rear, a vacuum system immediately transfers the freshly picked flowers into a sealed collection chamber, where cool air, maintained below 20 degrees Celsius, preserves their natural essential oil content, the key factor that determines chamomile's value in the herbal tea, cosmetics, and premium pharmaceutical industries. Once the hopper is full, the flowers are unloaded into transport trucks and taken directly to cold drying and oil extraction facilities. Each year, over 70,000 tons of chamomile flowers are harvested across Europe and North Africa, thanks largely to these precision mechanized systems that elevate each tiny bloom into part of a billion-dollar industry. This season marks the peak harvest for hard-shelled squash varieties like kabocha and butternut. Specialized harvesters equipped with hydraulic lifting arms, stem-cutting blades, and steel spiral conveyors can gather and load tons of squash in a single pass. Their tough rinds make them highly impact-resistant, allowing the machines to cut, roll, and load the fruits directly into transport bins, replacing dozens of workers and reducing harvest time to just 1/10 of traditional methods. In contrast, yellow squash, one of North America's culinary icons, especially in Florida, demands the delicate touch of human hands. Its thin, tender skin is so fragile that even the slightest scratch can diminish its market value. Farmers must move carefully through dense rows of leaves using sharp knives to cut the stems, lifting each fruit gently with both hands, and placing it into foam-lined baskets. Once the baskets are full, they're quickly sent to washing, sorting, and cooling stations. The entire process completed within a few hours to preserve the squash's sweetness and vibrant color. In November, as Belgium's Chicory fields turn a pale golden hue, fleets of specialized harvesters roar to life, signaling the beginning of one of Europe's most precise examples of agricultural mechanization. Unlike standard carrot harvesters, Chicory root harvesters are intricate mechanical systems engineered specifically for this delicate, high-value crop, with its long, fragile roots. At the front, a high-speed rotary leaf-cutting drum neatly trims away the tops in a single pass, clearing the path while keeping the neck of each root perfectly intact. Immediately after, a pair of V-shaped steel blades slides about 30 centimeters deep into the soil, slicing gently along both sides of the root and lifting the soil bed in preparation for the hydraulic gripping system. Soft synthetic rubber clamps then delicately grasp each root and pull it straight upward, a seemingly simple motion that's nearly impossible to achieve by hand without breaking the root. Behind them, a series of cushioned rubber conveyors receives and cleans the harvest, shaking off soil through vibrating sieves before carrying the roots into the storage hopper. The entire process, from cutting and lifting to collecting, runs seamlessly, guided by GPS and depth sensors that ensure near-perfect precision at every step. With a wingspan of up to 40 meters and the ability to spray thousands of fine, mist-like water jets, the boom irrigation system before you is a trusted helper for Dutch farmers caring for vast tulip fields stretching over thousands of hectares. Its operation is impressively clever. The boom is extended to the area that needs watering, directly connected to water channels and a pressurized pumping system. Hundreds of tiny nozzles along the steel arms release water in unison, creating an artificial rain that blankets every row of flowers. Thanks to its even spray and ultrafine droplets, this system can save up to 40% of water compared to traditional methods, helping the tulips grow uniformly while keeping their vibrant colors intact. But to keep the tulips not just beautiful, but healthy, farmers rely on another shield: a self-propelled spraying machine with a tank holding up to 6,000 liters. The wingspan is still impressive, stretching wide across the field, but this time its mission has changed. Hundreds of nozzles release a fine mist, covering every petal and leaf, forming an invisible barrier against pests and mold. In just 1 hour, the machine can treat 15 to 20 hectares, dozens of times more efficient than manual labor, saving chemicals, reducing pollution, and ensuring every tulip reaches absolute perfection. But no matter how stunning the flowers are, they still need to be removed, because the real value Dutch farmers aim for lies underground: the tulip bulbs. Only by removing the blooms can the nutrients be fully directed to grow big, strong bulbs that meet export standards. The tulip cutting machine, or tulip topper, is designed compactly to fit neatly between rows for easy movement. At the front, specially shaped rotating blades cut only the flower heads, leaving stems and leaves intact to continue photosynthesis and nourish the bulbs. Thanks to this precision, hundreds of hectares of flowers are processed quickly and accurately, laying the foundation for the multi-billion-dollar tulip bulb industry each year. Unlike tulips, which are harvested with just a gentle cut at the bloom, lavender enters its season with massive machines, a clear sign of its importance, as it supplies up to 70% of the raw material for the global perfume industry. The cutter-gatherer works with rotating disc blades that slice close to the rows, then clamp and lift the purple stems onto a conveyor, compressing them into large bundles neatly dropped into a storage compartment. This method preserves the whole stems, producing pure essential oils, perfect for high-end perfumes or handcrafted dried bouquets. The trade-off, however, is a slower pace and the need for more handling afterward. On the other hand, modified Class Jaguar harvesters are built for speed. Their cutting blades and chain system continuously chop, shred, and suction the lavender, blasting the fragments directly into a truck driving alongside. This approach can clear hundreds of hectares within just a few days, saving on labor and costs, though the oil quality is slightly lower and usually destined for large-scale industrial use. Whichever technology is chosen, the goal remains the same: to transform the endless purple fields of Provence into the fragrant heart that sustains the world's perfume industry. The moldboard plow, the true season opener of every harvest, stands out with its ability to turn the very skin of the earth in a single pass, awakening the life hidden deep underground. Heavy-duty tractors boasting pulling power of 250 to 400 horsepower tow behind them a set of perfectly curved plow blades. Crafted from ultra-durable steel with smooth-flowing surfaces, these exceptional blades can slice, lift, and flip soil 180 degrees in just one motion. Thanks to their precise angles and polished finish, the soil doesn't shatter chaotically, but instead folds neatly into even strips, burying weeds, pathogens, and crop residues while bringing the fertile lower layers up to the surface. A modern moldboard plow on today's market ranges from $15,000 to $40,000, depending on its size and number of blades, excluding the tractor itself. It's a major investment, but one that pays off with unmatched efficiency across large-scale farmlands. On the vast fields of Idaho, the potato capital of the United States, Grimm potato planters have replaced manual labor with a 5-step process completed in a single pass, cutting down planting time, saving up to 70% in costs, and bringing agriculture to true industrial standards. At the front, tillers and furrow openers break up the soil, carving out perfectly straight rows. As the earth is turned, flocks of birds swoop down, snatching up the worms and insects that appear, turning the entire field into a lively feast where nature and machinery move in harmony. Immediately after, ridge formers shape the soil into uniform beds with precise dimensions. Behind them, massive seed hoppers feed tons of seed potatoes onto conveyors, dropping them through chutes at exactly the right spacing and depth. Just seconds later, covering discs close the soil to lock in moisture, while integrated fertilizing and spraying systems add nutrients and protect the crop from pests right from the start. Thanks to these steel giants, planting thousands of hectares, once a job that took weeks, can now be done in just a few days. Though the initial investment is significant, the efficiency they deliver makes them a golden asset for any industrial-scale farm. The impressive cup conveyor system is the true backbone of modern cauliflower harvesting. Once the heads are neatly cut at the base, workers carefully place them into bright yellow plastic cups, moving steadily across the field. Each cup acts like a personal, protective shield, cradling the cauliflower securely without bruising or scratching. Together, they flow in a seamless stream toward a central truck, where the cauliflowers are transferred straight onto the loading platform, ready for sorting and packaging. It's essentially a mobile production line in the middle of the field, fast, efficient, and standardized. But the pinnacle of technology lies in the autonomous robotic harvesting system for broccoli. These aren't just machines, they are intelligent arms working in perfect synchronization. Each robotic arm is equipped with a soft silicone gripper that holds the broccoli firmly without crushing it. Right at the gripping point, a high-pressure mist nozzle releases a burst of cold vapor, instantly chilling the freshly cut head to extend freshness and suppress bacterial growth. Then, with the help of an integrated vacuum lift, the broccoli is gently raised and either placed onto a conveyor or dropped directly into a storage bin. Though not yet widely adopted, and costing several times more than traditional systems, robotic technology is still seen as the inevitable future of smart farming, where productivity, quality, and sustainability converge in every field. Soaring across vast fields like the Sky Knights of the digital age, spraying drones are rewriting the standards of modern agriculture. Their impressive operation begins with GPS and digital mapping, allowing them to follow precise flight paths without missing even the smallest corner of a field. High-pressure nozzles combined with smart sensors distribute liquid according to crop density, cutting pesticide use by up to 50% while safeguarding maximum yields. With multi-directional radar and obstacle avoidance sensors, drones fly safely and steadily, even over terraced farms or rugged landscapes where traditional tractors simply can't reach. But spraying is just the beginning. These drones can also sow seeds, spread fertilizer, or even dispense granular pesticides, transforming into true multitasking machines in the sky. Faster, safer, and more precise, they're no longer just a supporting tool, but a symbol of smart farming, where technology quite literally takes flight alongside the harvest. On the vast dairy and beef cattle farms of the US and Australia, hay gathering is no longer the work of human hands, but of true steel rakers, the wheel rake. With star-shaped wheels bristling with slender steel tines, they spin freely with ground friction, sweeping scattered hay into long, uniform windrows in a single pass. Each synchronized turn creates a powerful mechanical rhythm, transforming the chaotic aftermath of harvest into neat rows ready for baling and storage. Without the need for complex hydraulics or sophisticated electronics, the wheel rake wins farmers over with its simplicity, durability, and remarkable speed. With low upfront costs, yet the ability to cover dozens of hectares in just a few hours, it stands as the unsung hero of industrial hayfields. The giant John Deere spindle picker C770 stands as the ultimate symbol of America's cotton mechanization era, bringing in millions of tons of cotton each season from September to October. At its front, a spindle system armed with thousands of high-speed steel needles spins relentlessly, twisting each boll from its husk with near-perfect precision, while stripping away leaves and impurities. But what truly sets the C770 as a global benchmark is its integrated module builder. Instead of transporting harvested cotton to a separate gin press, the machine compresses it instantly in the field into massive round modules weighing 2-3 tons, wrapped in moisture-resistant film, and neatly dropped on the spot. This leap transforms the C770 from a mere harvester into a mobile harvest baling storage line, streamlining the entire post-harvest chain, cutting labor costs and preserving fiber quality at its peak. Behind the millions of tons of bright red tomatoes harvested each year, it's no longer the bending backs of workers picking basket by basket, but the rise of tomato-pulling machines, the true path clearers of modern farming. With powerful steel arms, they gently lift entire plants from the soil, lining them up neatly in rows to await the next stage of harvest. Instead of dozens of workers uprooting by hand, now a single machine can sweep across the entire field in a matter of moments. but that is only the beginning. Right behind them come the steel giants that transform the open field into a massive outdoor factory. As they move through the rows, the front-end shakers yank whole tomato plants from the earth and feed them onto a moving conveyor. There, a series of vibrating sieves shake relentlessly, stripping ripe fruit from stems, leaves, and soil, leaving only a flowing stream of crimson tomatoes. The true breakthrough lies in flawless synchronization. Once cleaned by high-powered fans, each fruit glides down the belt and is instantly handed over to a truck driving alongside. No stoppage, no manual hauling. Harvesting, sorting, cleaning, and loading all unfold in one seamless motion. With just a single machine, dozens of hectares can be processed daily, yielding hundreds of tons of fruit, compressing weeks of back-breaking labor into only a few days. This is how industrial agriculture turns a tomato harvest into a breathtaking performance of speed, power, and precision. Every journey begins with the soil. Dragon fruit thrives best in loose, well-drained soil, rich in organic matter, with a pH between 5.5 and 6.5. That is why sandy loam and well-aerated gray soils become the ideal environment for roots to anchor deeply and unleash vigorous growth. Before planting, the fields are thoroughly plowed during the dry season to clear away weeds, especially persistent grasses like kogan or wiregrass, and root-eating pests that drain nutrients from young plants. If ignored, the cost of eradicating them later would rise sharply. Once the soil is ready, the next step is to set up the posts, the backbone of an entire dragon fruit orchard. Farmers usually use concrete or hardwood posts, about 2 meters long, buried nearly half a meter deep for stability. The part rising 1.5 meters above the ground is fitted with curved iron rods, forming a support for the canopy to spread. During scorching summers, concrete posts can absorb heat and damage the plant's delicate roots. To prevent this, skilled growers wrap the posts with layers of rice straw, dried banana leaves, or old burlap sacks. This humble covering acts like a suit of armor, reducing heat and protecting the young plants during their most vulnerable stage, until they grow strong enough to thrive. Once the posts stand tall like milestones, the choice of cuttings determines success or failure. Each cutting must come from a healthy mother plant, at least 6 months old, with dark green, plump stems about 50 centimeters long. It is estimated that in just 1 hectare, around 7,000 quality cuttings can double yields compared to planting inferior stock. The round, firm clusters of spines along each node are clear signs of vigorous growth, the foundation for an orchard to flourish in unison. Once the soil and cuttings are ready, the next step is to create space for the plants to reach upward. Dragon fruit is a sun-hungry crop, so farmers usually set the posts about 3 meters apart, wide enough for each branch to stretch toward the light. On 1 sow of land, roughly 1,000 square meters, over 100 posts are neatly arranged, forming bright, airy orchards where every branch has the chance to capture sunlight and photosynthesize to its fullest. When the cuttings are selected, they are planted about 4 centimeters deep. The core must be firmly embedded in the soil to prevent root rot, while the stem is tied securely against the post. Skipping this simple step means that just 1 strong gust of wind could topple the young plants. Typically, each post carries around 4 cuttings, creating the initial framework for the entire orchard. As As soon as the cuttings are planted in the soil, water becomes the lifeblood that sets the entire journey in motion. The fragile young plants must be watered regularly, typically every 3 days, to keep the soil moist. When the scorching summer heat stretches on for months, farmers skillfully cover the base with a layer of rice straw or coconut fiber. This humble cloak not only keeps the soil cool and suppresses weeds, but over time it also decomposes into natural nutrients, quietly nourishing the plants day by day. For dragon fruit to grow strong and sustainably, it needs to be refueled in time. Farmers usually spread organic or inorganic fertilizer in a circle a short distance from the base, then cover it with a thin layer of soil and water it in. This method allows the roots to spread wider, absorb nutrients more efficiently, and minimize losses. Nature grants dragon fruit only about 3 natural harvests a year, but with artificial light, that number can rise to nearly 10. In mature orchards, rows of electric bulbs glow through the night, transforming dark fields into a sparkling galaxy. It is this light that compels the plants to bloom out of season, allowing farmers to control supply in line with market demand. When the flowers bloom, only a few strong ones are kept on each branch. Once they set fruit, the thinning continues until just 1 or 2 of the healthiest remain. This practice allows the chosen fruits to grow faster, with firm, glossy skins, sweeter flesh, and higher commercial value. Typically, dragon fruit takes only about 30 to 50 days after flowering to ripen, depending on the variety. This is considered remarkably short compared to many other fruits such as mangoes, oranges, or tangerines. To preserve freshness, dragon fruits are harvested in the early morning or late afternoon. An orchard can yield dozens of tons in a single crop, yet harvesting remains almost entirely manual. The reason lies in the fruit's unique growth. It clings tightly to the post, is surrounded by ears and spines, and ripens unevenly on each plant. Using machines to clamp, shake, or cut in bulk would easily bruise the skin, break the ears, or snap the stems, lowering the fruit's commercial value. For this reason, workers patiently move between rows, carrying small shears, bending down to inspect ripeness before cutting by hand. One hand holds the fruit firmly, the other makes a clean cut, leaving a stem of about 3 to 5 centimeters. Immediately afterward, the fruit is placed gently into baskets, ready to be taken to the collection point. After being harvested, the fruits are brought to collection points, stacked in plastic crates, and transported directly to the factory. During transit, temperature and ventilation are strictly controlled to prevent wilting or bruising, ensuring the fruit retains its quality before entering the processing line. Upon arrival, crates of vibrant red dragon fruit are taken straight to the reception area. Here, they are weighed and given an initial sorting by hundreds of workers before officially moving onto the modern processing line. Next, the dragon fruits enter a continuous washing system. Multi-directional water sprays combined with disinfecting rollers remove every trace of soil, sand, and dust, leaving the surface naturally glossy. The process is repeated through several washing chambers, like a double shield, ensuring each fruit is perfectly clean before moving forward. Leaving the wash station, the fruits are carried onto conveyor belts, where leaves, broken stems, and damaged fruits are eliminated. Automated rollers and electronic scales then grade them by weight and size, sorting them into uniform groups. At the end of the line, workers conduct one final inspection, keeping only those fruits that are flawless in both color and shape. Fruits that meet the standard are surface dried, then neatly arranged into trays or paper-lined cartons. Each batch is wrapped with a breathable PE film or mesh bag, complete with traceability labels and export stamps. For demanding markets such as the United States, Europe, or Japan, the fruits must also undergo irradiation or hot water treatment to meet strict phytosanitary requirements. Finally, the cartons, each holding about 8 to 10 kilograms of dragon fruit, are sealed and placed into cold storage to preserve freshness. From there, refrigerated containers carrying dozens of tons are dispatched to seaports or airports, delivering this precious sweet flavor to consumers around the globe. The journey of almonds begins in January or February, when young almond trees are planted in California's Central Valley, the almond capital of the world. With its hot, dry climate and fertile soil, the region offers ideal conditions for these trees to thrive year-round. At first, the trees are planted in evenly spaced rows and paired with drip or micro-sprinkler irrigation systems, which deliver water and nutrients with precision and efficiency. Modern drip irrigation systems allow water to go directly to the roots, minimizing evaporation and waste. Meanwhile, micro-sprinklers help maintain even soil moisture and deliver fertilizers through the water, supporting healthy growth throughout the tree's life cycle. What sets almonds apart from many other crops is their deep root system and high water demand. This is largely because their growing season coincides with California's dry months, requiring consistent watering to maintain tree health and productivity. Although drip irrigation helps conserve water, the fact that almonds bear fruit annually means water consumption remains high to sustain yields throughout the production cycle. In the first 1 to 2 years, farmers focus on developing strong canopies and healthy root systems. Modern machinery is used to prune dead or overlapping branches, ensuring each tree receives ample sunlight and grows vigorously. By the 3rd or 4th year, when the trees bloom in vibrant shades of pink and white, the pollination season officially begins. At this time, over 2 million beehives are brought into almond orchards. The bees gently collect pollen from the newly blossoming flowers. With their busy wings, they transfer pollen from one blossom to another, promoting fruit development in the almond trees. For years, almond growers have partnered closely with beekeepers to ensure successful harvests, a collaboration that supports healthy trees and high yields for seasons to come. After months of care under the summer sun, by late summer to early fall, the green outer hull of the almond begins to split open, like a smile from nature, signaling that harvest time has arrived. To harvest almonds quickly, a machine called a tree shaker is used. The tree shaker is an agricultural engineering marvel, equipped with a mechanical arm and hydraulic drive system that clamps securely onto the tree trunk. When activated, it produces rapid and precise vibrations, almost like dancing with the tree, creating a joyful rain of almonds that fall evenly and efficiently. Each tree shaker can harvest 10 to 15 almond trees per hour, depending on its size and capacity. In the past, farmers had to shake trees manually using long poles, which was time-consuming and posed safety risks. The advent of the tree shaker has drastically shortened the harvest period from several weeks to just a few days, reducing labor costs and nut loss while boosting overall production efficiency. After the almond rain from the tree shaker falls to the ground, a modern device called a sweeper is used to make the harvesting process easier. The sweeper is equipped with rotating brushes that gently sweep the almonds into long, straight rows, known as windrows. These rows are neatly arranged between the tree lines, creating tidy strips of nuts, ready for collection. The machine operates smoothly, allowing for quick gathering while minimizing damage to leaves and soil. Organizing the almonds into windrows helps the harvesting equipment work more efficiently, speeds up the collection process, and protects nut quality by reducing breakage. After a few days of sun drying to reduce moisture and improve nut quality, the main harvesting phase begins. Almond sweepers move along the windrows, collecting the nuts and transferring them into specialized trucks. These machines are often equipped with advanced fans and filtering systems that help remove leaves, twigs, and dust, ensuring that only clean, intact almonds are gathered. As a result, post-harvest processes like sorting and processing become easier and more efficient. Finally, the harvester began pushing rows of almonds onto the long conveyor belt. The nuts poured into the truck bed like a small stream, layer upon layer, dusted with soil and kissed by the sun and wind, painting a vivid picture of the harvest season. In just a moment, the truck bed was piled high with mountains of almonds, ready to set off, carrying with them the breath of the earth and the hopes of the farmers for a bountiful season, beginning a new journey from orchard to table. When almonds are transported to processing facilities, they often still have their green outer hulls and hard shells, along with some debris such as dry leaves, small twigs, and soil. Before hulling begins, the almonds undergo a thorough cleaning process. First, they pass through a desticker machine, which removes larger branches without damaging the nuts. Next, the almonds move to the destoner, where a stream of air blows away lighter debris, while vibrations help dislodge any hardened soil clinging to the surface of the nuts. Finally, the almonds pass through a detwigger, which completely removes any remaining small twigs and impurities. The next step is hulling. The process begins by loosening the green outer hull using a gentle rotating or friction mechanism. The loosened hulls are then removed by a vacuum or air suction system, ensuring the production line remains free of impurities. After the outer hull is removed, the almonds are transferred to a gravity table to separate any remaining debris. Nuts that still have their hard shells continue along the main processing line, where they pass through a camera-based inspection system that detects and removes any substandard almonds in preparation for the next shelling stage. The shelling process begins by feeding the almonds, still encased in their hard shells, into a specialized shelling machine. This machine uses gentle mechanical force to crack and separate the shells, while ensuring the almond kernels inside remain intact and undamaged. After shelling, the almonds are transferred onto a vibrating conveyor, equipped with sorting holes to classify them by size. Smaller kernels fall into separate bins and are typically used for almond butter or baking ingredients. Larger kernels continue down the line to meet the standards of premium markets. It is common for the upper class to leverage their financial and social power to pay a significant premium for the privilege of securing the highest quality almonds during the very process in which they are being sorted. In a high-tech environment, almonds undergo quality inspection using advanced computer software. Supercomputers operate around the clock to identify almonds that meet strict quality standards. Next, high-resolution scanning cameras detect tiny cracks or surface scratches on each almond. The system then calculates the exact coordinates and sends the data to robotic arms. These robotic arms swiftly and precisely remove the defective almonds from the processing line. Finally, human workers perform a final inspection, removing any remaining defective almonds to ensure the highest quality. The almonds are then sorted into bins of different colors based on their quality. Red bins typically hold premium-grade almonds, while green and yellow bins contain second-grade ones. This manual sorting process helps detect subtle imperfections and handle special cases, tasks that automated systems may not execute perfectly. Steam pasteurization is the most common method used in the United States, in which hot steam is applied for a short duration to eliminate harmful bacteria such as Salmonella. This process is highly effective, preserving the natural flavor and texture of the almonds while meeting strict food safety standards. After pasteurization, the almonds are moved to the packaging stage. Large bins are carefully prepared and securely sealed to preserve freshness and quality during transport. These bins are then delivered to specialized processing facilities. There, the almonds continue their journey, being transformed into delicious products such as salted roasted almonds or sweet almond toffee.